Seating arrangement. Jonathan, one of the sponsors at the African Mining Indaba, has booked a large banquet room at the convention center for a business dinner. There will be 24 delegates, and in order to seat them, he needs to arrange for tables. 8 people can sit at one rectangular table. He wants to arrange all the tables in a rectangular shape, such that it will look like one long table. There are a limited number of tables available. However, Jonathan does not want any seats to be vacant in his arrangement. What is the smallest number of tables that he will need to book to host all the delegates in one long table with no seat vacant? Also, write down a formula to calculate how many people can be seated using n tables. Solution. Let us note down the given data. If we need to make one long rectangular table, the tables must be placed next to each other, edge to edge. If we join another table, the total number of delegates that can be seated becomes 8 plus 6 equals 14. Because we lose 2 seats by joining the edges of the table, by joining 3 tables, Jonathan can seat 20 delegates. If we continue in this manner, we can see a sequence being formed. The common difference of the sequence is 6. We can see that every additional table gives Jonathan 6 more seats. So if Jonathan books one more table, he can seat 26 delegates. However, booking 4 tables will not help us, since Jonathan does not want any seats to be left vacant. So, we will need to find another way to seat the delegates. How about arranging the tables by joining the longer edges? The seating capacity of one table is 8. If we add another table in this arrangement, we can seat 2 more people. The total number of delegates seated will now become 10. Likewise, if we join 3 tables in this arrangement, we can seat 12 delegates in total. We can tabulate this data to extend the pattern to find the number of tables that will be needed to seat 24 delegates. We need to find n when Tn is equal to 24. We can calculate the common difference from this sequence, p, which is 2, as 2 people get added each time to the table. The general formula for its sequence is given as Tn equals 2n plus q. Substituting the values for the second term, we get q is equal to 6. The general formula for this sequence is Tn equals 2n plus 6. To find n when Tn is equal to 24, we substitute the values in this equation. 2n plus 6 equals 24. Therefore, n is equal to 9. Hence, Jonathan will need 9 tables to create one large table to host all the delegates if he wants to ensure that no seats are vacant. In this arrangement, using n tables, 2n plus 6, delegates can be seated.
Need more help? Subscribe to our channel. Can't wait that long? Ask Maski to help you and let the math finally start mathing.